The figure shows the VT graph of a particle moving along a straight line. The time when the particle returns to the starting position will be equal to. Now basically I will divide the graph along the two sections. First is from O to A when the particle is accelerating, and from O to B when the particle deaccelerates and it comes to rest. Now we have to find out the total displacement when the particle returns to the starting point. The total displacement I will divide it into two parts, that is S1 plus S2. S1 is the displacement between point O to A and S2 is the displacement between the point O to B when the particle returns to its original point. Now since the total displacement is 0, I can write this as 0. S1 is the displacement when the particle is accelerating. So basically it will be the area under this graph, which will be equal to, area under this graph is equal to half into base into height, which is equal to half into base over here is equal to 20 into height over here is equal to 20 plus the value of S2. Now S2 will be equal to, if I calculate this value, it will come out to be minus 200 meter. Okay, S2 will come out to be minus 200 meter. Now S2 can be written as ut plus half at square. Now the initial velocity between A to B is, now whether S2 is given as minus 200. The initial velocity between point A to B, the initial velocity over here is, I can clearly see it is as 20, it is positive 20. Okay, now the velocity is equal to positive into t plus half acceleration. Okay, acceleration into t square. Let us find out the value of acceleration. Acceleration will be equal to v minus u divided by t. That is the slope of this graph. Now the velocity at this point, if I write down the coordinates, it will be equal to 25 comma the velocity is equal to 0. Now this coordinate will be equal to 20 comma 20. Okay, so basically the x-axis it is equal to 20, y-axis it is equal to 20. So basically 0 minus 20 is equal to minus 20. Okay, 25 minus 20 is equal to 5. So the acceleration is equal to minus 4 meter per second square. So I will substitute over here minus 4 into t square. So over here it will be equal to minus 200 will be equal to 20t. Okay, which will be equal to minus 2 t square. So t square minus 10 t, okay, my t square minus 20 minus 100 will be equal to 0. So basically over here t square minus 10t minus 100 will be equal to 0. We have to find out the time period. Now the time period will come out to be over here. I will, now in order to obtain 100 over here, the only option is equal to minus 10, which is not available. Okay, so it will be equal to minus b plus minus root of b square minus 4ac, okay, divided by 2a. If I calculate the value over here, the positive value I will get is approximately 17 seconds. Okay, the positive value I will get is approximately 17 seconds. Okay, so basically after 17 seconds it will come to rest. So it means that after 17 seconds it will come to rest. So the original time period from the starting, it will be equal to 0 to 20, okay, plus 20 to 17, okay, which will be equal to, total time period will be equal to 37 seconds, after which the body will come to rest.